Okay, just checking that we're recording. And I'm live. So, given us problem number 8, given a singly linked list, write a function to swap elements pairwise. For example, if the linked list is 1, 2, 3, 4, 5, then the function should change it to 2, 1, 4, 3, 5, where each pair of two elements has been swapped in position. Okay, this function is going to take, I haven't had my coffee yet. It's going to take a singly linked list in and return a node out. It could take a node and return a node, but I'm going to do it like this with the class I've developed. Okay, I'm going to use Q1 and initially assign to list.head. I'm also going to use P2 and assign to the next of list.head. I'm going to create new P1 and assign this to list.head initially. And I'm going to create previous tail. Okay. Those are the nodes I'm going to store. So to iterate, I'll use a while loop. While P1 is not null, and P2 is not null. I'll first handle the reassignment of the head. If the P1 is list.head, if this is our first time through, then we need to switch P2 and P1 and also reassign the head. So storing what's going to be the new P1. Nullify the next pointers. And connect the head to P2, P2.next to P1, and P1.next to new P1. Awesome. We also need to handle what happens when we're not at the beginning of the list. There are two cases. I'll outline those first. So the first case is if we're not at the end of the list. If P2, because you can have an odd number of elements right here, 1, 2, 3, 4, 5. So if P2.next is not null, so we'll handle that. We're not at the end. Else, we are at the end. When we are not at the end, we will assign what the new P1 will be to store where we'll pick back up. We'll nullify P1, then we'll nullify the next pointers. Break everything up. And then we will move the then we will move the brief tail.next pointer to p2, p2.next to p1, and p1.next to new p1. So else if we are at the end here, p1.next, the next pointer needs to be nullified, and connect the remaining elements. Okay, and outside of this block of if else, but inside the while loop, we need to handle the reassignment of these variables. So brief tail is going to be assigned to P1. It's going to hold the ending pair from the last set. So when we're switching P1 and P2, it becomes P2, P1. P1 is the previous tail of that pair. P2 is assigned to P1.next. And P1 is assigned to new P1. Finally, outside of the while loop, I'll return the head. Okay, let's run through a test. I will shorten this. And we'll go 1, 2, 3. So right now, head is 1, P1 is 1. P2 is 2. New P1 is list.head. And brief tail is list.head. While P1 is not null and P2 is not null, amazing. If P1 is list.head, yes it is. New P1 is P2.next. Okay, P2 is 2, P2.next is 3, so new P1 becomes 3. Alright. P1.next is null. Nullify this pointer. P2.next is null. Nullify that pointer. This dot head is P2, so that's not what I want. Head points to P2 is 2, so I'll just put, these are all floating in space right now, and this also points to null. Okay. List.head is P2, great. Update list.head. P2.next is P1. Draw that pointer in. And we're missing an equal sign. P1.next is new P1. P1.next is new P1. Oh, this pointer never, no. Okay, new P1 is 3, P1.next. This pointer gets assigned there. P1.next is new P1. Okay, so we come to the end here. Prev tail is assigned to P1. P1 is currently 2? No. P1 is still 1. Oh, I don't have a marker for list that head up here. Okay. What I was doing is prev tail is now assigned to P1. Okay, which it already is 1. P1 is assigned to new P1. So now P1 is 3. P2 is P1.next. 3.next is null. P2 is null. Now our list is 2, 1, 3, which is what we want. Let's see what happens. Well, P1 is not null and P2 is not null. Well, P2 is null, so we return list.head.